In previous lecture, we have completed the design of beam when it is subjected to torsion. In that, I was solved four problems with having a different details. Okay, so please go through it and try to prepare your own notes. Okay. Now we are reaching towards the next part of this subject. It is again a design of a beam, but the beam is continuous beam. The beam is continuous beam. So what is exactly the difference? Why we have to study these separately? Okay, that part I will cover. Okay. So now we are going to unit 2. Okay, the heading is continuous beam. Heading is continuous beam. That means design of a continuous beam, analysis of a continuous beam. RCC design of continuous beam. Okay, RCC design of continuous beam. RCC design of continuous beam. Already I have told that what is exactly the design of beam. Design of beam is nothing but you have to decide the dimensions of beam. You have to design the longitudinal reinforcement, tension reinforcement at bottom. You have to find out the compression reinforcement at top. And finally, the main thing, you have to design the shear reinforcement. That's it. If you done all these things, the design of beam is completed. Now, why we are specially studying the design of a continuous beam? Design of a continuous beam. That I explain it. Okay. So basically, we know that continuous beam is an indeterminate structure. Continuous beam is a indeterminate structure. Okay. I want to sketch one beam. Okay. I want to sketch one beam. So this is a continuous beam of 3 span. Continuous beam of 3 span. When beam is having more than 1 span, more than 2 support is treated as a continuous beam. Now exactly what is the behavior of continuous beam when the load is applied on it? How it bends? Okay. So when load is applied on the beam, when load is applied on the continuous beam, the bending behavior of a beam is like this. The bending behavior of a beam is like this. It bends in span and again on support, bend in span, again on support, bend in span like this. That means there is development of span moment and development of support moment when loading is applied on continuous beam. So this is the span moment, this is the span moment, and this is the support moment. Span moment and this is the support moment. So while designing the continuous beam, you have to consider these two types of moments, span moment as well as support moment. That means before going to design, the main thing is how to analyze the continuous beam. How to analyze the continuous beam. That means the main important interesting part of this unit is to analysis of continuous beam. Analysis of continuous beam. That means in this unit First we have to go for the analysis of continuous beam, and second part is design of continuous beam. Okay, so before going to design, first you have to take care of analysis of continuous beam. Already I have told you the continuous beam is the best example of indeterminate structure. So what is indeterminate structure? So the indeterminate structure is structure which cannot be analyzed using our main equilibrium conditions, that is summation fx is equal to 0, summation fy is equal to 0, summation m is equal to 0. Using that equilibrium condition, we cannot analyze we cannot find out the all unknowns of the continuous structures. Okay, so you have to consider some special equilibrium conditions to analyze, to find out the unknowns from the continuous structures, indeterminate structures. Okay, is it clear? Now, what about the analysis of continuous beam? Now I am concentrating on analysis of continuous beam. Okay. Analysis of continuous beam. Analysis of continuous beam. For analysis of continuous beam, mainly there are two approaches you have to consider. One is the exact approach and second is the IS code approach. That means you have to use the exact method for analysis of continuous beam and you have to use the IS code method for analysis of continuous beam. Okay, so first one is the exact methods, and second one is the IS coefficient method. That means you have to use these two methods for analysis purpose. You have to use the two methods for analysis purpose. Now, if IS code method is available in IS 456, then what is the importance of the exact method? What is the importance of the exact method? Why we have to study the exact method? Okay, because the IS coefficient method is having so many restrictions. As per the IS 456, it having some points. If that points are satisfied, then you have to use the IS code method. Now I am going to tell you exactly which are the exact methods you have to adopt for the analysis of a continuous beam. We know that in exact method, the first typical and easiest method is moment distribution method. Moment distribution method. Already we learned this method in previous semester in theory of structures. Okay. So exact method, the simplest method is the moment distribution method. You use this method and analyze the continuous beam. Okay. Second one, slope deflection method. Slope deflection method is the one of the simplest method that you can use to analyze the continuous beam. Third one is the three moment theorem method. three moment theorem. You can use the three moment theorem and analyze the continuous beam. Again, next one is the consistent deformation method. Okay, consistent deformation method. Okay, and last one, matrix method. Last one, matrix methods. Okay, the matrix methods are Stevens matrix method and flexibility method. Use that method and analyze the continuous beam. Okay, if you want to use the exact method, you have to adopt these four methods, 1 2 3 4 5, sorry, 5 methods, and analyze the continuous beam as per your requirement. But the simplest method frequently adopted by practitioners is the moment distribution method. It is called shortly as MDM. It's called shortly moment distribution method. Don't go for these methods for analysis purpose. Use this moment distribution method and analyze the continuous beam. Okay. These methods are exact method. These methods are applicable for the all types of beam. Whether the load is equal, whether the load is unequal, whether it is load in form of UDL, whether there is a point load, span is more than 2, span is more than 3, whatever is there, these methods are applicable for analysis purpose of continuous beam. Now, what about the IS code method? The IS code method already we have learned this method in last semester, design of concrete structure 1, for analysis of continuous slab, that is IS code on page number 36. It provides table 12 and table 13, it having a bending moment coefficients. Okay, directly you use these coefficients and analyze the continuous beam. But the IS code gives some important points. If these points are satisfied, then you have to use the coefficient method. When these points are satisfied, then you go for the coefficient method. What are that points? That points are directly given on page number 35, clause number 22.5.1, that is moment and shear coefficient for the continuous beam. So what points you have to consider for application of this method? What points you have to consider for application of this method? Okay, the first point is loading is uniform. That means when there is a UDL on beam, then only this method is applicable. Okay, applicable for only UDL. Applicable for only UDL. When UDL is there on continuous beam, this method is applicable. Second point, 3 and more than 3 spans. Okay, 3 and more than 3 spans. When continuous beam is having 3 and more than 3 spans, then this method is applicable. Okay. Third point, equal spans. When the spans are equal, then this method is applicable. But when there is a difference, IS code clearly says here, okay, 3 or more spans which do not differ more than 15%. If there is a difference between the span values, okay, if difference between the span values, okay, when there is a difference between the span values, that difference should not be more than 15%. Okay, difference not more than 15%, then this method is applicable. Look here, for only UDL, the continuous beam having point load, it is not applicable. For only UDL, when continuous beam is having UDL, then this method is applicable. When 3 and more span, then this method is applicable. And for equal spans, difference between the spans values, if there is a difference between the span values, that difference should not be more than 15%, then this method is applicable. Please remember this. Okay, if these 3 points are satisfied, then you go for the I-squared method for the analysis of a continuous beam. Otherwise, you go to the moment distribution method. Okay, so this clause, these points, okay, these all points are given on page number 35. Okay, page number 35 and clause number 22.5.1. Refer this clause and use the I-squared coefficient method. Otherwise, go for the moment distribution method. This is for the continuous beam. Because the continuous beam is indeterminate structure. For indeterminate structure, you have to use the special methods for analysis, and 2 approaches are there. One is exact method, another is the I-squared method. In exact method, simplest method is moment distribution method. Use this method, analyze the continuous beam, then design the beam. And another method is the I-squared method, but I-squared method having so many restrictions. Okay, the restrictions are only UDL. If UDL is present on the continuous beam, then it is applicable. 3 and more spans, for 2 spans it is not applicable. Okay, 3 and more than 3 spans it is applicable. Again, for equal spans, equal loading, equal spans and equal loading. Okay, but when there is a difference between the span values, okay, that difference is not more than 15%, then this I-squared method is applicable. Is it clear? Okay. So this is related to analysis. Now, what is loading combination on continuous beam? Okay, arrangement of loads. Okay, loading arrangement on continuous beam. Loading arrangement on continuous beam. Okay, when we get the maximum positive moment, when we get the maximum negative moment, that part I am going to tell you. Okay. Next, that is for maximum negative moment. When we get the maximum negative moment at which loading arrangement, at what loading arrangement we get the maximum negative moment. Okay, so the beam is continuous. Beam is continuous. Okay, when beam is continuous, if the loading, maximum loading is provided, if the maximum loading is provided, W max, okay, if the W max, if the maximum loading is provided,